Okay, so in the last class we just finished before the infinite sets. So here we will start from the infinite sets. Okay, so just in its name it says that infinite, the sets which we can't count are called as the infinite sets. Just like the set of natural numbers where we starts from 1, counting from 1. So 1, 2, 3, 100, 1000, lakhs, crore, arab, and it goes on. So we can start counting but we can't finish it. Okay, so this set is called as the infinite set. But what about the real numbers? We know that there are any kind of number which you can imagine is called as the real numbers. Just it includes rational number and irrational numbers as well. Also the natural numbers, whole numbers, integers. Real numbers hasn't come yet in your syllabus, but rational number, the set of rational number is kind of a set which is countably infinite. Okay, uncountably infinite, because we can't even start counting this set. So this is also an example of infinite set. So and there comes a set of integers. Okay, so the integers starts from minus infinity and ends in plus infinity. Any negative numbers which can be think as the starting point, and any positive number. So and it will goes on. If I take minus 10 as the starting point of this set, so it will be goes as 0, 1, 2, 3, 4, and that. This is also an example of infinite set. Okay, the next one. Okay, so we have already done a few maths by explaining this property of set, empty set or null set. Okay, an empty set, also called a null set, is a set that contains no element. It is the unique set with no members or element. Just like I have told that no elements, that means that set doesn't have any kind of element. Just like we write set by writing the second bracket, and then we write the members of the set inside that bracket, but for empty sets we won't write any kind of members. So this will be the example of this set. Okay, so we can also denote this set as this is called as the phi. This is also a Greek alphabet which used to denote the empty set, or we can say this set as the null set, or even we can say this as void set. Okay, so that there are two properties of this kind of set, that the empty set contains no element, its cardinality or the number of elements in that set is 0. So we can say that, or this n of phi will always be 0. Okay, this is called as the cardinality of any set, and it's the subset of every set in the universe. Yes, we haven't learned about subset yet. We will learn in few minutes. So this is called as the subset of any set in this universe, or it becomes the subset of any set in this universe naturally. Okay. Now we will learn about the disjoint sets. Okay, so disjoint sets are two or more sets that have no elements in common. In other words, the intersection of disjoint set is the empty set. It is denoted as A intersection B equals to phi. Okay, so let me explain it a little bit. Like if I take a set A which has elements 1, 2, 3, 4, and let me take another set B which has element 5, 6, 7 and 8. So here are the two sets. So in these two sets there are no elements in common. Okay, so if I like 1, 2, 3, 4, no one is common. 5, 6, 7, 8, no one is common. So this set will be called as the two completely different set or the disjoint set which don't have any connection in it. Okay, and this we will discuss in further. Okay, I haven't told you about this symbol yet. This is the intersection symbol. Okay, let me write it a bit in it. So clear? The next one. Next we will learn about the joint set. Sets having at least one element in common are called joint set or overlapping set. It's denoted as A intersection B equals to phi. Okay. Just if I write a set A which is 1, 11, 1, 1, 1, 1, 1, 1, 1, and another set which goes like this 1, 10, 100, 1000. So these two set has one element in common, that is 1 itself. Okay, so this set can be called as the joint set. Okay, they have at least one element in common. Okay, and just like the previous one, I will explaining it a little bit in further, because this is also the intersection symbol. Okay. Okay, then now is the equal set. Two sets are said to be equal if the elements of both the sets are the same. Okay, just like this one example of this one, I am telling you that A set contains X, Y and Z, and another set B which is containing the last 3 letters of English alphabet, and we all know that English alphabet ends with X, Y and Z. So these two sets will contain the same elements, and those are X, Y and Z, and these X, Y and Z are contained by two different sets. So from this conclusion we can say that set A and set B are the same. Okay, so it also been done. Okay, the next one is equivalent set. If two sets are said to be equivalent if they have an equal number of elements in them. Just like if I write a set A which has 1, 2, 3 in it, and another set B which has A, B, C in it. It has 3 elements and this also has 3 elements. Yes, just for the number of elements are same, so their cardinality will also be same, because the cardinal number is the number of members in that set. Okay, so that's why we can say that A and B, these two sets will be equivalent. Okay, got it? And we can also denote by both sided arrow, denote this set as the both sided arrow. Okay, and also just like I tell that n of A will be equal to n of B, because the cardinality will be the same and the members will be the same, or number of members will be the same. The next one. Okay, now we will going to do some math. In a shopping mall there are two types of shop: 15 clothing stores, 10 electronic stores. 5 stores sell both clothing and electronic. So C represents the set of clothing stores, E represents the set of electronic stores. How many clothing stores do not sell electronics? How many stores sell either clothing or electronics? And C, are the sets C and E disjoint? So this is the question they are asking. So let's solve it. So here the clothing, there are 15 clothing stores, 10 electronic stores and 5 stores which are selling both. Okay. So we will just, from 15 stores we are subtracting 5, so it becomes 10, and from 10 stores we are subtracting 5, which becomes 5. So there are 10 stores which sells only clothes or clothing, and there are 5 stores which sells only electronics. So clothing stores that do not sell electronics is equals to 10. So this is the simple. We can also do this math by using Venn diagram as well. Maybe this is not, that's not included in your syllabus, but let us see that how can we do it. Okay. Now the subset. Okay. So this is also an important part. A subset is a set where every element of that set is also an element of another set. In other words, if you have two sets, say A and B, A is a subset of B if every element in A is also in B. This is denoted as yes, it doesn't have the correct notation, so this will be denoted as like this: A is a subset of B. So let me explain it. So here we can take a set which includes E, F and G. Yes, these three are from the alphabets, English alphabets, and another set B which contains 26 letters starting from A to Z. Okay, so it will contain A, B, C, D, dot dot dot, and it will end with X, Y and Z. So we can say that E, F, G is also a part of the set B. So we can say that A is a subset of B, and we will denote it as like this. Okay, because the set A, the elements of set A will also contain in the set B. So E, F, G is the subset of, A is a set which contains E, F, G, which is also member of set B starting from A to Z. So we can say that A is the subset of the set B. Okay. The next one is superset. A superset is opposite of subset. A set B is called as a superset of A if every element of A is also an element of B. In notation, we write this like this. We say that B is a superset of A. Okay. So let me explain it like this. If we go by the same previous example, a set A has elements E, F and G, and another set B has elements starting from A, B, C, D, dot dot dot, X, Y, Z. Okay, so all the elements in A are part of the is part of the set B or the elements in set B. So A is a or B, so B is to be called as the superset of set A because all elements are part in the set B. Okay. Next is the proper subset. A is a proper subset of B because all elements of A are in B, but A is not equal to B since B has an extra element. Just like these two sets, A is equals to 1, 2, 3, B is equals to 1, 2, 3, 4. So A is said to be the proper subset of B if all the elements present in A is part of the set B. Okay, and we will denote this as the A subset of B. This is also called as a subset. We can also call it as a subset, but in special cases, subset doesn't represent the proper subset. That's why we have differentiated it from the subset. So proper subset and subsets generally the same or become the same. Okay. Number of subset and number of proper subsets of a given subset. If A set has n elements in it, the number of its subset will be 2n and the number of its proper subset will be 2n minus 1. Okay. Let me explain it a little bit. A set A has 3 elements 1, 2 and 3. So, if we make all the subset of this set, what it will be? First of all, phi will be a subset of the set A because phi is the subset of any other set. Okay, so then there will be a set A, a set. Okay, so 1, 2, 3 is 1, 2, 3 B in a single set will also be the subset of it, and just like it will be 2 and 3, 1 and 3. 1 and 2, so 1, 2, 3, 4, 5, 6, 7 and 1, 2, 3. So yes, maybe I have thrown it a bit away. If I write all the subset of this set A, so we can tell that phi 1, 2, 3, 2 and 3, 1 and 3, 1 and 2 and 1, 3, 1, 2 and 3 again. So there will be 8 subset of this set A. So there are 8 subsets and the member of this set is 1, 2 and 3. So this will be a simple formula 2 to the power n where the n means 3 will be 8. Okay. So there will be 8 subsets. So it doesn't matter how many elements living in any set, like if I write A, B, C and D, there are 4 elements in this set. So the number of subset of this set will be 16. Okay. The next one is the number of its proper subset. We know that. What about the proper subset? If the same set becomes that set again, so this will be called as a proper subset. So we will just cancel or we will just minus 1 from that set. If I write like 2 to the power 4 means 16 set, if we cancel only this set from the list of the subset, then this will be, those will be the proper subsets of this set. Okay, got it, understand? Okay, now a number of elements AB, and that means that it has only two members, so the n will be 2, and just I have said it before. Okay, the next one. Okay, now we will learn about the universal set. Okay, so universal set are the biggest set which we just think or consider by doing any of the set. Sometimes it is being given, but sometimes we think the set of natural numbers, the set of real numbers, or the set of rational numbers, these as the universal set. Just if I let that U is the set of universal numbers, and 1, 2, 3, 4, 5, 6 are the members of this set, and a set A which is smaller than this universal set, which has members like this 3, 4 and 5, and B is also a set which have members 1 and 5. So we will denote this set as like this box, where 5 is the member of both of this set, so that's why this is in the middle, and 3 and 4 is part of A, and B is the part of another set, and 6 and 2 is not part of any set, but it is the part of a bigger set. So this is called as the universal set, and this set, which is denoted by U, is called the universal set because this set contains all the elements in it. Okay, just like if I so I am taking a set, universal set, which is starts from 1, 2, 3 and goes up to 100, and a set A which contains 15, 16, 17, 18, 19 and 20, and another set B which contains 10, 11, 12, 13, 14 up to 20. So this set so here we can write in the universal set 1, 2, 3, 4, 5 up to 100, but there are some elements which is not a part of the set, so we can say that from 15, 16, 17 to up to 20, this will be part of this set, and in B there are sets containing from 10, 11, 12, 13 up to 20. Okay, so then you will see that there won't be a set B like this. This will be A and this will be B, and the total whole set will be the universal set. Got it? Okay, just like the same way they have did this, we can also make any question and solve this. Okay, so let's solve a little bit of questions. Okay. Okay, we will start from this, the cardinal number of sets. So X is a letter in the word algebra. So in this maybe we have done this before the last class. If not, then I am doing it again. Okay, so this set will contain the members which will be A, L, G, E, B, R. Okay, A comes 2 times, so we won't write A again. So it will be A, L, G, E, B, R. Okay. The next one, X is a natural number between 15 and 20. So there are 4 numbers, 16, 17, 18, 19. These 4 numbers will be part of the set B, or will be the numbers of set B. The last, the third one you can do it in your home. The fourth one can also be done in your home. Okay. Okay, now we will learn about the equal or equivalent set. Okay, so what we have learned about equal and equivalent set, that if the number of members or the cardinality or the cardinal number is the same, then those sets are said to be equivalent set. So you can see that in set A there are 4 members, 1, 2, 3, 4, and in set B there are also 4 members. So these two sets are equal set as well as the equivalent set. Okay. The second one is also like this. First, in C they have written all the members, and in D they just written it in a descriptive form. So the vowels in the English alphabet, okay, which are A, E, I, O, U. So these are also the equal set. Okay. The third one is in the set E. There are 3 members, red, blue, and green, and in F there are 3 members, circle, square, and triangle. So members are the same, but in members they don't have any kind of connection. Red, blue, and green are the colors, and circle, square, and triangle are the shapes. So they don't have anything in common, but just one thing is common, that is in these two sets, that they all have only 3 members. So we can say that these two sets are equivalent set. Okay, equivalent but not equal. The same goes for 4 and 5, which you can done in your home. Okay. The next one we will learn about the subset. The subset and superset. So in the first one, U is a set which contains elements starting from 1 to 10, and A is another set which contains even numbers starting from 2 to 10, and B is 1, 2, 3, and C is 2, 3, 4, 5. So they are saying us that B is a subset of U. Obviously yes, because B contains 1, 2, 3, and U also contains 1, 2, 3. So B is a subset of U. Is C a subset of A? So yes, C will also be a subset of A, because all the members in C are also the members of U. List all subsets of B. So B will have 8 subsets by the rule of 2 to the power n, and B has 3 members in it. So it will be 8 subsets. The subset which you can write in your home easily. Which sets are subsets of the universal set U? So these three sets are also the subsets of the universal set U. And the fifth one is A a superset of C? I am giving it to you. You have to think and write it and show me the copies in the next class. Okay. It's like your homework. So now we will learn about the operations on set, which is not very much included in your books as well, but we will learn some for the basics, and it's specially meant for the higher classes, but we will learn it from here a little bit. Okay, so the union of sets A and B is denoted by so they are written by this symbol. This a symbol like U, this represents the word union. And union means if a set has 4 elements 5, 6, 7, 8 and a set B has also contains 4 elements 4, 6, 8 and 10. So A union B will contains all the elements from set A or from set B. Okay, so this will be like we will start from 4, then will be 5, 6, 7, 8, okay, 4, 5, 6, 7, 8, 9 and 10. You can see there are 2 elements 6 and 8 which are present in the both set A and set B, and as per the sets logic sets definition we won't write any element double. Okay, so that's why we haven't written 6 or 8 2 times but written it in one single time. Okay, so this will be the definition of A union B. The next one, the intersection of any set. The intersection of two sets A and B is the set which contains elements common to both A and B. Just like the previous one, A and B, these both set has 6 and 8 in common. Okay, so A, this symbol means intersection. Okay, so this will contain elements 6 and 8. Okay, so just like example of this one, these both set, A set contains 5, 6, 7, 8, 9 and B set contains 4, 6, 8, 10. And 8 and 5 both are present in these both sets, so they have written it like middle. Okay. We will, if we learn it by Venn diagram, the Venn diagram represents, if these two are sets, then when A union B will be represented by like, oh sorry, A intersection B will represent like this. Okay, and if these two are sets, then A union B will be represented by like this. A elements also have so many, A set also has so many elements, B set will also have so many elements. So A union B will represent the elements of these two sets together. Okay. Okay, I have already told about the intersection, and okay, now we will learn about the differences of set. If a set A is known as 5, 6, 7, 8, 9 and the set B is known as 4, 6, 8 and 10. So A minus B will be, A set has 5, 6, 7, 8, 9 and B has 4, 6, 8 and 10. So we will omit 6, we will omit 8 and nothing else. So the answer will be 5, 7 and 9. Just like the normal subtraction, these both set have B set has 6 and 8 which are also present in the set A. So we will just cancel 6 and 8 and this will be the answer. A minus B will be 5, 7 and 9. Okay. Just like if I do this reversely, like for B and A, so what it will happen? So this also, B also has 4, oh, no, not 4. Achha, B also has 6 which will be omitted and also has 8. So 8 will be. So the B minus A will be 4 and 10. So this is just the operation on set or the subtraction operation or the difference operation on set. Okay, and if we go by Venn diagram, so then A minus B will represent this and B minus A will represent just like this. Okay, the next one, test yourself. At a birthday party, there are two set of people. Set A, children who like chocolate ice cream. Set B, children who like strawberry ice cream. Okay, so this is your homework. You can do it easily by using Venn diagram or just writing it in the description form. Okay, I am giving it for your homework. Okay. The next one also. Okay, so the cardinal property, we already have learned about the cardinality. So now we will going to learn cardinal property is also the same as the cardinal number. If a set A has 10 elements in it, we say its cardinal number is 10 and we write it as a n of A. In cardinality, we just written it just like this. But if I talk about cardinal number only, we will denote it like this. This will represent as the cardinality and this will represent the cardinal number. Okay, and that's all. Let us solve a little bit questions from it. Okay. So what we have learned in the universal set, that a set which has elements like this set is the universal set and this set is also contains elements which 4 elements from the universal set. So the complement of this set, which will be denoted like this, will be these 4: B, D, F and H. Okay. So the complement of any set is the set, the elements which is not present in that set but also present in the universal set. Okay. So in the set X there are 4 elements present, and in the universal set there are 8 elements present. So the 4 elements which are not present in X will be called as the complement of set X. Okay, got it? Okay, so first one has been done. Find the complement of set X. Okay, so complement of the complement, that means X set X का complement होगा X dashed और X dash का complement होगा फिर से X. So ये X वाला सेट ही होगा, तो ये भी हो गया easily. What is the union of set X and its complement? तो X और X का complement का अगर हम लोग यूनियन बनाएं तो क्या होगा, ये U सेट ही होगा फिर से, ये U सेट ही होगा फिर से. ओके, okay, the 4 and 5 is homework for your home. Okay, I am ending this class here. So the set chapter is being completed in 2 classes, and I already covered all the topics in it, but if you have any kind of doubt you can reach out to me. Okay, so I am ending this class here. Okay, goodbye.